Assalamu alaikum and a very good day. My name is Muhammad Izzan bin Abdul Samad from BEEA Section 1 Group 1 metric number B082110004. Today I will be conducting my video presentation on the liftable face shield design using AutoCAD and Meta Control under Meta Hackers. I will show a demonstration on how I draw my completed face shield, which is consisted of 4 parts, which is consisted of the main face shield holder, the holder for the face shield, the strap, as well as the tightener for the overall face shield. Now I will show a demonstration on how I draw each important part using AutoCAD. Now I will show you how I draw the basic structure of the face shield mainframe and how I draw the basic structure of the face shield holder frame. In which later on I was able to use the press pull command to complete the basic structure of both of these frames. Now I draw, add and extrude all the important details to my face shield holder mainframe. This is how I add the most important feature, the swinging pin, to allow the face shield holder frame to swing when needed. This is how I add the holes to the mainframe face shield and how I smoothened it to allow the strap to go through. And now I will show you, via this demonstration, how I embroidered my name to the face shield holder frame. And at this part, I will show how I designed the tightener for the overall face shield holder. And now I will show how the strap is drawn in AutoCAD. For your information, this strap is to show how the complete face shield looks like, and the square parts, the square solid parts are shown as the sewed parts of the strap to the completed face shield. And finally, I will show you how I assembled all of these four main components to represent the complete face shield design. This picture shows the face shield dimensions of my completed face shield, which can be referred to in the AutoCAD file. My completed face shield design is shown in these two pictures, which is in this color, and it is also embroidered with my name, colored white as shown here, completed with the strap shown here, and also the tightener for the face shield as shown here and here. For the estimated mass and printing time, there are actually several factors that affect this section, which include the size of the object, the height and complexity of the object, as well as the printing technology used during the printing process. These factors can cause the printing time to vary as little as 30 minutes or as long as several days. The bigger the part and the greater the complexity, the longer it takes to print. However, a simpler and smaller item can be printed much faster. For my completed face shield, it takes about 2 hours and 3 minutes, which is the average printing time for most 3D printed face shields. But my design is simpler, as it is easy to draw in any software and light in terms of total mass. The picture here shows the estimated mass and printing time for both the face shield holder and the tightener for the face shield holder. I was able to obtain these printing times and estimated masses by changing the slice settings in the meta control, which is for the face shield is a thickness set to custom balanced and with a light fill density, and for the tightener is a coarse thickness with a light fill density. From the research that I have done regarding on the many types of 3D printed objects, the common type of material used as a filament material for 3D printing is called polylactic acid or PLA. However, for the use of printing 3D face shields, I intend to use the variant of polyethylene terephthalate, which is PETG, as it is an increasingly popular 3D printer filament. The G in PETG stands for glycol. As a material for 3D printing, it is naturally clearer, less brittle, and most importantly, easier to print than its base form. For this reason, PETG is considered a good middle ground between ABS and PLA, where it is actually more flexible and durable than PLA and easier to print than ABS. Compared to PETG is readily recyclable, making it a lot more eco-friendly. There is a bio-PETG filament variant, which is more eco-friendly, but it can come at a higher price. For this case, I use the standard PETG filament for this face shield. For the cost of the face shield, based on the estimated mass, I set it to around 2 ringgit and 27 cents, and for the tightener, I set it to around 6 cents. Added with the manpower cost of 1 ringgit, the strap cost of 50 cents, which can actually be bought separately, and the assembly cost of 33 cents, it brings to a total of 4 ringgit and 16 cents. However, the total cost of the shield, added with the profit of 20%, is 5 ringgit. The cost is reasonable as the design is simple yet effective, and it's within the average price range of 4 ringgit to 40 ringgit per face shield, inclusive of the strap and tightener. If the client requires 100 pieces of my already completed face shield, that would give a total cost of 500 ringgit. The price for 100 pieces of this face shield holder is also reasonable as similar mask designs may be more expensive due to larger quantities or a larger estimated mass. For reference, I was able to obtain these pictures to help me complete my video presentation for this face shield. This is to show the basic structure of my face shield and how it operates, how I attach the face shield, and how it's worn by the users, and how to adjust the face shield according to the user's comfort. Throughout this video presentation, I would like to highlight some important details. Firstly, the strap and tightener shown in AutoCAD is to show how the complete face shield looks like, but both the tightener and face shield are printed using the same material, which is PETG. The strap is made up of a single, flexible, elastic, and comfortable strap that can be removed and adjusted to fit the user's comfort. The tightener at the back acts as a tightness adjuster similar to that of a bag strap tightener as shown in the reference pictures earlier. The strap can be bought separately as it is easy to obtain due to high demand, especially in 3D printed face shields. Throughout the last 2 years facing the COVID-19 pandemic, it has become clear that both face masks and face shields are equally important as they act as tools to stop the spread of this virus. During this pandemic, personal protective equipment, or PPE, has become a major demand and has opened up new opportunities for innovative designers, mainly in 3D printing such as face shields. A prime example is the many types of 3D printed face shields shown today, in which they use it to open up a business. With various designs of 3D printed face shields, they are arguably best at protecting other wearers from coughs and sneezes, as it prevents the air droplets from reaching those people. In correspondence to this, it is important to follow up on the latest healthcare guidelines and manage our health by having the most suitable PPE according to our preferences. In conclusion, despite the long printing time of 3D face shields, they are easy to design and can be adjusted according to users' comfort. This makes the face shield design throughout this presentation worth the price for its general application. I hope that my face shield design can be recognized and taken by our Kementerian Kesihatan Malaysia as a reference and can be used by all the frontline workers who risk their lives and work hard to control the current situations on COVID-19. That is all from me. I would like to thank you all for watching, and I hope that this video presentation fulfills the objectives of this video presentation for my AutoCAD course. Thank you.